Something just woke up in Iceland, and nobody is talking about it the way they should be. 13 earthquakes, one volcano, one single day. That's not background noise. That's a system reactivating. I've been tracking the Reykjanes Peninsula for over 3 years now, and what just happened at Fagradalsfjall? I need you to understand what this actually means, because the mainstream coverage is completely missing the bigger picture. So let's get into it right now. Fagradalsfjall. Say that name. Remember it. Because this volcano has a history of doing exactly what scientists said it wouldn't do, and then doing it anyway. For months, this system was quiet, eerily quiet, the kind of quiet that makes volcanologists uncomfortable. And then, in a single 24-hour window, the seismic network surrounding the Reykjanes Peninsula lit up with 13 distinct earthquakes clustered directly beneath the Fagradalsfjall volcanic system. That's not random. That's not coincidence. That's a pattern I've seen before, at this exact location. Let me show you exactly why this matters. Fagradalsfjall sits on the Reykjanes Peninsula, a jagged finger of land that juts southwest off Iceland's main island directly into the Atlantic. This entire peninsula is essentially a crack in the Earth's crust sitting on top of the mid-Atlantic ridge, where the North American tectonic plate and the Eurasian tectonic plate are literally being pulled apart at roughly 2.5 centimeters per year. Think of it like this. Imagine two pieces of bread slowly being pulled away from each other. The cheese in the middle? That's the magma. It stretches, it thins, and eventually it tears. That's the Reykjanes Peninsula, every single day. But here's what makes this recent swarm different from normal background seismicity, and this is the part no one is pointing out. The earthquakes in this swarm weren't random scatter. They weren't distributed widely across the peninsula the way typical tectonic settling looks. They were concentrated, clustered, focused beneath a specific zone of the Fagradalsfjall system that has been the nucleation point for every single eruption this volcano has produced in its recent reawakening. And Fagradalsfjall has been on a very specific schedule. March 2021, after 781 years of silence on the Reykjanes Peninsula, Fagradalsfjall erupted. Scientists were stunned. The system had been considered essentially dormant for nearly 8 centuries, and then, just like that, fire. August 2022, it erupted again. Shorter warning, faster onset. July 2023, a third eruption, even more vigorous. The lava field from that event, called Litli Rutur, covered over 3.6 square kilometers of land in under 3 weeks. And then came the Svartsengi system, activating just to the west in late 2023, threatening the town of Grindavík, forcing mass evacuations, sending lava flowing toward the Blue Lagoon geothermal spa. That system erupted multiple times through 2024. The entire Reykjanes Peninsula entered what geologists are now formally calling an eruptive episode, a period potentially lasting decades where these volcanic systems cycle through eruptions one after another. Now stay with me, because what comes next changes everything. The swarm at Fagradalsfjall isn't happening in isolation. It never does. These systems talk to each other through the crust, not metaphorically, literally. Pressure changes in one magma body can influence stress conditions in adjacent systems through a process called static stress transfer. When Svartsengi has been erupting and releasing pressure to the west, it changes the mechanical stress field across the entire peninsula, including directly beneath Fagradalsfjall. I'm not saying an eruption is imminent, but I find it very interesting that the last 3 times Fagradalsfjall produced a seismic swarm of this character, concentrated, shallow, with this specific spatial pattern, an eruption followed within weeks to months. Let that sink in. Now, here's something I've been watching that almost nobody is reporting on. The Icelandic Meteorological Office, the IMO, they don't just track earthquakes. They run an incredibly sophisticated network of GPS ground deformation sensors across the Reykjanes Peninsula. And ground deformation is the real tell. It's the difference between earthquakes caused by pure tectonic movement, plates shifting, and earthquakes caused by magma movement, molten rock forcing its way through cracks. When magma moves, the ground above it swells, inflates, like a balloon being slowly pumped up from below. We are waiting to see whether the deformation data correlates with this swarm. If it does, if the GPS stations near Fagradalsfjall start showing even a few millimeters of uplift, that changes the alert level conversation entirely. And that data should be coming in within the next 24 to 48 hours of this swarm being recorded. I'm watching it in real time, and you should be too. But that's not even the real story here. The real story is what this means for the long game, for the decades-long volcanic awakening that Iceland's southwest is going through right now. The Reykjanes Peninsula had an eruptive period roughly 800 years ago. Historical records and geological dating show it was characterized by multiple eruption sites firing up sequentially, sometimes simultaneously, over a period of roughly 200 to 300 years. Then it went quiet, for 781 years. And now it's back. We are not at the beginning of a single event. We are at the beginning of a multi-century chapter. And the 13 earthquakes that just rattled Fagradalsfjall are one line in that very long chapter being written right now beneath our feet. The geological term for this is a volcanic reawakening episode. And the hard truth that most science communicators won't say plainly is this: we don't fully know the rules for how this unfolds. Because the last time it happened, there were no seismometers, no GPS satellites, no infrared satellite monitoring, no real-time gas spectrometry. We are watching something ancient happen for the very first time with modern eyes, and every data point matters. Now here is where it gets interesting, because Fagradalsfjall is not just scientifically significant. It sits in a zone that has massive practical implications for people, real people, living and working nearby. Keflavik International Airport is roughly 20 kilometers from the Fagradalsfjall system. This is Iceland's primary international hub, the airport through which the vast majority of Iceland's 12 million annual tourists pass. The airport through which critical air freight moves across the North Atlantic. Remember Eyjafjallajökull in 2010? That eruption, which was actually far smaller than many of Iceland's systems are capable of, grounded over 100,000 flights, disrupted air travel across Europe for 6 straight days, caused an estimated $1.3 billion in economic damage to the airline industry alone. Fagradalsfjall's eruptions so far have been what volcanologists call effusive. That means lava flows, relatively low explosive index, relatively low ash production, not the type of eruption that shuts down airspace. But here's the thing, the system can evolve. Eruption character can change, and if magma begins interacting with groundwater or ice at depth, the explosive potential increases dramatically. I'm not saying that's happening, but the 13 earthquake swarm is a reminder that this system is active, dynamic, and capable of changing character. Is this a foreshock sequence leading to something larger? Could the reactivation of Fagradalsfjall trigger renewed activity at Svartsengi? These are not hypothetical questions. These are the actual questions being discussed in Icelandic volcanology circles right now. As I'm recording this right now, the IMO's earthquake catalog is still being updated. The preliminary magnitudes from this swarm ranged from small microseismic events barely detectable without instruments up to magnitudes around 2 to 3, not felt strongly at the surface, but absolutely meaningful at depth. What matters isn't the magnitude at the surface. What matters is the depth distribution. Shallow earthquakes, above 5 kilometers, in a volcanic zone are a very different signal than deeper tectonic earthquakes at 10 or 15 kilometers. Shallow means the crust is fractured and permeable. Shallow means fluids, whether hydrothermal water, volcanic gases, or magma itself, are moving through the upper crust. The preliminary depth reports on this swarm are showing activity concentrated in that upper crustal zone, and that is significant. Now, what I'm about to tell you, most people have absolutely no idea about. There is a monitoring threshold called the traffic light system used by Icelandic authorities and civil protection agencies. Green means normal background activity. Yellow means elevated unrest, increased seismicity or deformation beyond baseline. Orange means eruption likely or imminent. Red means eruption in progress. Prior to this swarm, the Fagradalsfjall system had been sitting at effectively green, quiet enough that it had dropped from active monitoring priority after months without significant activity. A swarm of 13 earthquakes in 24 hours is exactly the kind of trigger event that can shift that assessment to yellow. And that shift, even to yellow, triggers a cascade of preparedness protocols. Aviation authorities are notified. Emergency response teams go on standby. Additional monitoring resources get deployed. Evacuation route plans get reviewed. This is not panic. This is exactly what a well-prepared volcanic monitoring system is supposed to do. Iceland has one of the most sophisticated volcanic response frameworks on the planet, and that framework is being tested right now. But here's the question that keeps scientists up at night. What if this swarm isn't Fagradalsfjall reactivating independently? What if it's a response to pressure changes propagating from the Svartsengi system to the west? The two systems are connected through the same crustal network. They share the same deep magmatic plumbing in ways that are still being mapped and understood. Eruptions at Svartsengi have released significant volumes of magma over the past year. And when a magma body deflates in one location, it changes the stress balance for adjacent chambers. Think of it like squeezing a water balloon on one side. The pressure goes somewhere else. The question is where, and whether that pressure finds a pathway up. I've been tracking this specific stress transfer hypothesis for months, and this swarm, in this location, at this timing, lines up with exactly what that model would predict. That's not coincidence. That's geology doing what geology does. Stay with me, because what comes next changes everything. Let's zoom out for a moment, because the Reykjanes awakening doesn't exist in a vacuum. It's part of a global picture of volcanic unrest that 2024 and early 2025 brought into sharp focus. The Santorini caldera in Greece, quiet for decades, began showing elevated seismicity and minor deformation signals in late 2024. Santorini's last major eruption around 1600 BC is widely believed to have contributed to the collapse of the Minoan civilization. Campi Flegrei in Italy, the supervolcanic field beneath Naples, has been in a slow-motion uplift crisis for years. Bradyseism, the ground literally rising and falling as magma and hydrothermal fluids move at depth. The latest uplift measurements show the ground near Pozzuoli has risen by over a meter in recent years. And now Fagradalsfjall is showing renewed signs of life. I'm not saying the Earth is entering some kind of synchronized volcanic catastrophe. Volcanoes don't coordinate. But patterns of unrest across multiple systems do tell us something about the dynamic state of the planet's upper mantle, about where heat and pressure are finding pathways to the surface. And right now, in 2025, there are more simultaneously restless volcanic systems on Earth than at any point in recent decades where we've had this level of monitoring. That context matters, because it tells us we are in a period where surprises are more likely than average, where systems we thought were stable are revealing themselves to be less stable than assumed. Fagradalsfjall told us that in 2021, when it erupted after 781 years of silence, it's telling us something again right now. The question is, are we listening? Now, here's where I want to talk directly to you, because you asked the most important question anyone can ask in a moment like this. What does this actually mean for me? If you are in Iceland, particularly anywhere on the Reykjanes Peninsula or near Grindavík, you already know the drill. The Icelandic Civil Protection Authority has run multiple evacuation exercises. The alert system is mature. If authorities issue guidance, follow it immediately, not after you pack your things. Immediately. For those watching from outside Iceland, the immediate risk to you from this specific swarm is essentially zero. This is not Yellowstone. This is not a civilization-ending scenario. Iceland's volcanic systems, as dramatic as they are effusive dominant. They pour lava. They don't typically detonate. The risk calculus for the rest of the world runs through air travel disruption, through potential impacts on Iceland's geothermal energy infrastructure, and through the scientific ripple effects of whatever data this system produces. Because here's what most people don't realize. Iceland's volcanoes don't just affect Iceland. The North Atlantic Flight Corridor is one of the busiest in the world. Any significant ash-producing eruption in Iceland affects transatlantic aviation, period. That's your stake in this. Even if you're watching from Chicago or Sao Paulo or Dubai. What I'm watching for in the next 72 hours is this. Are there follow-on earthquakes? Does the swarm continue or does it die out quickly? Do the GPS deformation sensors pick up any uplift signal? Does the IMO change its assessment language? Any one of those indicators shifting would be significant. All of them shifting simultaneously would be extraordinary. I'll be updating as data comes in. Because this is what we do here, we stay on the pulse so you don't have to chase it yourself. And look, I've been right about this system before. When activity at Svartsengi was first escalating in late 2023 and most coverage was downplaying it, I told you the eruption risk was real and the timeline was short. Grindavík evacuated within weeks. The Blue Lagoon closed. Lava reached the roads. I'm not telling you to panic now. I'm telling you to pay attention. There's a difference. Because Fagradalsfjall is not a sleeping dragon that woke up irritable. It's an active volcanic system in the middle of a generational reactivation period. And every swarm, every tremor signal, every millimeter of ground deformation is data. Data that tells us how this chapter of Earth's story is being written. 13 earthquakes in one day after months of quiet is not nothing. It's a sentence in that story. And I want you reading every word alongside me. If this video found you at exactly the right moment, if you feel like you just got information that actually matters, then you already know what to do. Stay connected to this channel, because when the next update drops on Fagradalsfjall, and there will be a next update, you'll want to be here for it. This isn't about views. This is about being part of a community that takes the planet seriously, that doesn't wait for the news cycle to catch up, that understands the Earth is not a stable backdrop for human civilization. It's a dynamic, living system that demands our attention and our respect. And right now, it's asking for both. Iceland's southwest is speaking. 13 times in one day it spoke. And I will keep translating that language for you for as long as this system keeps talking. Because the Reykjanes Peninsula is not done. Not by a long shot. The next 72 hours are critical. I'll be watching the IMO feeds, the GPS networks, the tremor plots, the satellite thermal imaging, everything. And when something moves, and something will move, you'll hear it here first. The Earth doesn't stop, and neither do we.